Hi everyone, welcome to lesson 1.2. Please make sure you have your Springboard book open to page 7 and a pencil highlighter combo and your vocab list handy and a calculator handy if needed. Now, I know I just told you that we are starting on page 7, so here we are with the learning targets. We're going to talk a little bit more about vocabulary. But what I actually need you to do beyond looking at the learning targets is move on to page 8 so we can focus on this math tip box because there are 4 very important vocabulary words right here in this math tip box, and that is acute angle, right angle, obtuse angle, and straight angle. So make sure you highlight those, put a big star next to them because they're very important. You'll actually probably see them on your vocab list as well. Big terms for us today. Now, what we're going to start by doing is drawing those 4 vocab words, and we're going to start with the acute angle. So when we have an acute angle, that's going to be an angle between 0 and 90 degrees, but it does not measure 90 degrees. So we're going to call our angle A, B, C, or we'll call it angle 1, depending. And this angle, you can see it is less than our 90 degrees. Okay, 90 degrees would be a right angle, and a right angle is going to be represented by measuring exactly 90 degrees. Now, how we represent that, we're going to call this angle DEF, and how we can be sure that this is a right angle is you're going to usually see a box marked on that picture to identify that. Or if they tell you some angle is 90 degrees, you're allowed to put that box there. That's kind of your indicator that it is exactly 90 degrees. Now, our next type of angle we talked about is an obtuse angle. And an obtuse angle is when your angle is bigger than 90 degrees, but less than 180 degrees. So we'll call this angle X, Y, Z, or maybe we can call it angle 3 because it's the third one we talked about. This was angle 2. And notice this is between 90 degrees and 180 degrees. It's a little bit wider. Finally, if we have exactly 180 degree angle, that's going to be our straight angles. Now you're probably saying, C-check, this looks like a line to me. But we're going to talk about the fact that this is an angle measuring 180 degrees. So it looks like a line. But again, you would name it as an angle QRP, or maybe we named it angle 4. We're not talking about a line right now. We're talking about the angle measure. Now, there are also some other important terms when we talk about angles that we want to talk about. If we look at letter A, up above, we talked about the fact that angle 1 here would be classified as an acute angle. Angle 2 would be an obtuse angle. But what you're going to notice together, they created a straight angle. What we would call that is supplementary. And the fact that they are next to each other, notice they share between them this ray right here, and they have a common vertex, we would call that adjacent. So I would like you to take a moment to write down those 2 vocabulary words. Again, adjacent means that the angles are next to each other. They share this ray here. And supplementary means that the angles added together here are a straight angle. They're 180 degrees. Now, the next piece also involves 2 acute angles. And this time, while they're still adjacent to each other, notice they have that common vertex of D, and they extend out to part B. They're adjacent, but instead of being supplementary, what we would call this is complementary. So notice they add up to equal 90 degrees because we have that little box there. So this is what we would call complementary. So that's another vocab word you're definitely going to want to write down over here in your notes. Now, letter C, you're going to notice these are not adjacent to each other. They do not share a vertex or a ray. They're both acute because they measure less than 90 degrees, and they're still going to be complementary because their measures add up to equal 90 degrees. So they can still be complementary even though they are not adjacent. Now, you might be able to predict on letter D then some other things. Again, angle DEF is acute. Angle XYZ is obtuse. They are not adjacent to each other because they don't share a side, but they are supplementary because their measures add up to equal 180 degrees. All right. Now, just as a side note, because I sometimes get kind of lazy on the notes because I run out of room, I sometimes will call supplementary sup, this, SUPP. I call complementary a lot of times comp, and I call adjacent ADJ, just so you know my abbreviations. Now, moving on then. So we talked about the math tip box on this page already, but now as we are back on here, what you're going to notice here is that we have two pairs of intersecting lines here. So we're creating, a couple acute angles like angle 6 and angle 4. We also have two obtuse angles like angle 3 and angle 5. And if we ask you to name which two angles are supplementary to angles 4 and 5, hopefully you're going to answer correctly in that that's going to be angle 3 is supplementary to angle 4 and angle 5 is supplementary to angle 4. Now, a couple things here that you're going to notice is that not only are angle 3 and angle 5 supplementary to angle 4, they're also supplementary with angle 6. Okay, so if we think about this, let's say that angle 4 equals 30 degrees. Well, that means angle 3 and angle 5 both have to be 150 because they need to add up to 180 degrees. That also means that angle 6 is going to be 30 degrees because angle 4 and angle 6 have to be supplementary to 3 and 5. So what we're going to see here is that angle 4 is going to have the same measure as angle 6, right? Now, there's a special name for these angles that are opposite each other, like angle 4 and angle 6 and angle 3 and angle 5. We call those vertical angles. And we're going to talk a lot more about vertical angles in time, but basically they're the angles that when you have intersecting lines, they are opposite of each other. So for instance, this angle here and this angle here would be an example, or this angle here and this angle here would be an example. Okay, there are angles that are opposite each other. All right, now we're going to skip over this piece here since we talked up above about some of these. And we're going to talk a little bit more now about the last little bit of vocab for the day, and that's going to be talking about circles. So again, some important vocabulary that you're going to want to mark with a highlighter and in your notes. And in a circle, we have 3 different vocab words here that are really important: chord, diameter, and radius. And we're going to use this vocab all year. Now, a radius, I have to draw this, is a segment with both endpoints, a radius is a segment with one endpoint on the circle and one endpoint at the center of the circle. So if we're drawing radius OA, right, we are going to have O as our center and A on the circle. This is going to be our radius. Okay. Now, a chord, on the other hand, if we look up above, a chord, make that red, is on a circle. Both endpoints are on the circle somewhere, but they don't have to pass through the center of our circle like OA did. So if this is BA, he has an endpoint at B and an endpoint at A on the circle. And then last but not least, a diameter is like a really, really big chord, I like to say, or excuse me, a really, really big radius, because it's two of them. It cuts through that center, but it has endpoints both on the circle. Okay? Now, something to notice here, our center then of our circle is going to be point O. So we would call this the center of our circle. Now, down below, the center of the circle is super important because that's how we're going to name a circle. So for instance, we would name up above, we would draw a picture of a circle and call it circle O because that's what its center name was. So down below here, you'll notice we have two different circles. Both of these would be named circle P. So that's why you got to be careful when you have concentric circles, meaning circles within circles. Kind of think of the target bullseye, because circle P refers to both of them. So what we would want to make sure we would do is that we call one of these circle P with radius PQ, and then we would want to identify the other circle differently. So we would call this one circle P with radius PR or RP. Last but not least, I want to bring your attention to number 9. In number 9 here, we are going to talk about this in that we have an angle and its name is A. And A is 42 degrees. So if we have a 42 degree angle, how big would we have to make an angle that is complementary to angle A? Well, as a reminder, complementary angles have to add up to equal 90 degrees. So what plus 42 equals 90 degrees? Well, hopefully you answered 48 plus 42 equals 90 degrees. So 48 degrees would be our answer. What about if we were talking about supplementary to angle A? Well, a reminder, supplementary angles add up to equal 180. So what plus 42 equals 180? You should have answered that 138 degrees adds up to equal 180 with 42. So that's how big your supplementary angle would have to be. Good stuff. All right, and look forward to your questions and working on the practice. Thanks, everyone.